Do alcohols, aldehydes and ketones undergo oxidation reactions? How can we use the knowledge of oxidation reactions we gain to distinguish between these different types of compounds? That's what this video is about. If you find this video helpful, don't forget to share, like and subscribe, and look out for new videos. Hi, it's Mr. T here. In this series of videos, we're going to look at the reaction of carbonyl compounds. That is, compounds that contain a carbon double bond oxygen. In the first case, we're going to look at some oxidation and reduction reactions that happen between aldehydes, ketones, and primary and secondary alcohols. So here is an overview of what I'm going to cover in all the videos. So this is a reaction, a map or a scheme of the different types of carbonyl compounds and the types of reactions and reagents that are used to make changes from one to the other. So we've got oxidation, reduction, substitution, condensation, hydrolysis, and acid-base reactions. Okay, so the first type of reactions we're going to look at are oxidation and reduction reactions. In particular, we're going to look at primary and secondary alcohols, how they're converted to aldehydes and ketones, and how ketones and aldehydes can be reduced back to secondary and primary alcohols. We'll also look at the reaction of primary alcohols through to aldehydes and onto carboxylic acids. And we'll also look at how we might carry out these types of reactions in the laboratory. Okay, oxidation of primary alcohols. So the first reagent we might use to oxidize a primary alcohol is permanganate. Now permanganate is a purple color when it's dissolved in solution. Often it comes in the form of potassium permanganate. It's KMnO4. To make it so that it's a useful oxidant, oxidant for this type of reaction, we acidify it by adding an acid to it, and we add it to a primary alcohol. Now notice here, our primary alcohol, when we add the reagent, the permanganate, acidified permanganate reagent, it becomes this intermediate compound, and I've put a square bracket around it because this compound is only there so far or as long as the next permanganate particle comes along and oxidizes it. So this is called an intermediate, this aldehyde, because the permanganate that's still surrounding in the solution will further oxidize it to a carboxylic acid. So this is an oxidation of a primary alcohol. It will go through an intermediate step of an aldehyde and to a carboxylic acid. We can also carry out this reaction with acidified dichromate or acidified potassium dichromate. We would take a primary alcohol again, we would add the reagent, acidified dichromate, and again we get this aldehyde intermediate, and that would further go on and react to produce the carboxylic acid. What if we had a secondary alcohol? Remembering, if we classify a secondary alcohol, it is an alcohol that has the OH, or the OH functional group, is attached to a carbon that is itself joined to two other carbons. So notice this carbon here of this attached to the OH group is attached to a carbon on the left and one on the right, two different carbons, so it's a secondary alcohol. Now in this instance, we can still produce a carbonyl functional group here, and this is actually a ketone. Now once we do this first step, a ketone can't actually form another carbon oxygen bond without destroying the main chain of the molecule or destroying the molecule. And in any of these organic chemical reactions, we're not interested in that. We're looking at making changes to functional groups to change the properties of these compounds. So this is as far as we oxidize it, from a secondary alcohol to a ketone. So I can also look at a tertiary alcohol. Now tertiary alcohol, because the carbon that is attached to the OH here has 3 other carbons it is joined to, I can't easily make another carbon-oxygen bond. I can't oxidize it with permanganate. The only way that it could be oxidized would be from some type of combustion that would destroy this molecule. So in the lab, when we're doing simple oxidation reduction reactions with permanganate and dichromate, tertiary alcohols do not react because we can't form another carbon-oxygen bond. Okay, so we can oxidize primary and secondary alcohols. We can also oxidize aldehydes. Now remember that aldehydes was the intermediate in the reaction between the primary and the carboxylic acid, but if we started with an aldehyde, we could add permanganate to oxidize it to a carboxylic acid. If we want to actually produce an aldehyde, there is a specific type of apparatus that we set up so that we can collect an aldehyde as it's reacting. So imagine that I set up this apparatus like this. There's a Liebig condenser on an angle in the middle here. We have a reaction flask, this round bottom flask on the left with a thermometer, so this is enclosed. We have a collection flask on the right, and what we do is we put into this reaction flask some ethanol and some acidified dichromate. Then what that's going to do is that will react on heating to produce ethanol and then on to carboxylic acid. Now what we plan to do is we plan to heat this mixture, and as the ethanol is being produced, it will evaporate. It will go past this joint down the right here into this condensing tube and condense back to a liquid, ethanol, and then it will fall down into this collection container here. So we collect the distillate here. Now the reason we do that, the reason we actually try and collect the ethanol as it's made, is if it stays in the mixture, remember from before, the ethanol will oxidize further to a carboxylic acid, and I want to collect it before it has the chance to react, to do its second reaction with dichromate, and I want to pull it across and collect it into this flask. So this is where the oxidizing mixture is. This is the condenser. We have cold water going in the bottom. Remember to make sure the sleeve is completely full of cold water, and then the warmer water will come out the other side. Interesting a point we need to make when we carry out this distillation is ethanol will condense at 21 degrees Celsius, so the water going in has to be quite cold. So we can do that by taking it from an ice bath, or we could be in a lab that has quite a cold water supply. Okay, so this is what I was talking about here. The ethanol goes through to the ethanol and then on to the ethanoic acid. If I want to get the ethanol, I need to grab it before it has the chance to react with the dichromate and become the ethanoic acid. And by heating this, what actually happens is the ethanol has a boiling point of 21. So if I heat this to 50, this mixture, then what happens is, because the mixture is at 50, as soon as an ethanol is made, it's going to become the gas, and it's going to boil off or evaporate off. That gas, remember, flows up the neck here and goes down the condenser and is condensed back into our ethanol that's collected as a distillate. So it never had enough time to react with a dichromate to make the ethanoic acid. Of course, there may be a small amount of this that does react on the way, and it would become ethanoic acid, but we're trying to get as much of that ethanol as possible from this reaction. This type of distillation works because we are heating the mixture at a boiling point between the ethanol that is the reactant and the ethanol that is the product we want. And so if it's at 50 degrees, then the ethanol is not hot enough that a lot of the ethanol is evaporating off or boiling off, so we're not losing that, staying in the mixture to react. but it is hotter than the boiling point of the ethanol, so it will react and go down the tube and into the collecting flask. What if I want to produce a ketone? So if we remember before, a ketone was just a secondary alcohol, and we were going to oxidize it and turn it into a carboxylic acid. Now if I take a ketone, it also might have a low boiling point, or it's very volatile, we can say. So what we do is we put it into this reacting flask and we heat it. Now because the reactants may, on heating and reacting, get above their boiling points or may start to evaporate off, we put the condensing tube vertically on top of this mixing flask, the round bottom flask here, so that any of our reactants or of the products that have been made that evaporate off and are going to escape become condensed back to a liquid or cooled down as they travel through this column and change from a gas back to a liquid and fall back into the mixture. So the evaporating chemicals are pushed back into the mixture. Again, it's important to make sure the cold water goes in the bottom, so the whole tube is surrounded by the cold water. If we just put it in the top, what would happen is it would fall straight to the bottom and then come out the bottom, and the tube would only have a little bit of cold water in it, and it wouldn't cool it down to the same extent. One thing to notice is we should always make sure this heating mixture flask is no more than 2/3 full. If it is higher than that, then bubbles may start to form up the neck and push up through the column and come out the top. Okay, so that's how we might oxidize or produce aldehydes and ketones from primary and secondary alcohols. If we want to turn an aldehyde or a ketone back into a primary or secondary alcohol, we carry out a reduction reaction. A reduction reaction involves us taking the aldehyde and adding sodium borohydride. And the sodium borohydride is a reducing agent. It will take away a carbon to oxygen bond, or it will facilitate, you can see it can add hydrogens here, but it basically, the sodium borohydride gets oxidized while the organic molecule is reduced. And in this case, we have an aldehyde being turned back into a primary alcohol by adding sodium borohydride. Of course, we can do the same with a ketone. We can turn a ketone back into a secondary alcohol, but this sodium borohydride will not work with the carboxylic acid. We cannot turn a carboxylic acid back into an aldehyde using this reagent. We can only go back from an aldehyde to a primary alcohol or a ketone to a secondary alcohol. Right, so let's have a look at the summary we have for the types of reactions we looked at in this part of the video. We looked at oxidation and reduction. So what I would like you to do, just pause the video, sketch down this reaction map and see if you can fill in the 3 unknown molecules. Look at what the molecules are that we have either at the starting or at the end of a reaction, and work out what the molecule would have been that made them or was made from them. When you've done that, restart the video and see what the answers are. Okay, so here we have this carboxylic acid. If we look here, it has been oxidized from an aldehyde. The aldehyde a carboxylic acid is made from is exactly the same carbon backbone, but the OH part here of the carboxylic acid is actually just an H in the aldehyde. So we can redraw that and it will look like this. What we can see here is the aldehyde was also oxidized from a primary alcohol. Now the primary alcohol that it was produced from will have exactly the same carbon framework again, but the OH had come off where the double bond O is. So what we would do here is remove one of the bonds from the oxygen, add an H to it, and add another hydrogen at the bottom. And this is the primary alcohol it was made from. So if we go over and look at the secondary alcohol for our ketones here, we can see that if we oxidize the secondary alcohol, we're going to get the carbonyl group coming off here, and this will of course be a ketone. So we'll have a carbon with a double bond off the middle. And these are the three diagrams we should have drawn. I hope that this has been helpful so far. Look out for the next part of the video where I'm going to look at carboxylic acids and substitution reactions. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those three questions. Hopefully this has fortified your understanding of geometric isomers and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.